Okay, today we are talking about lesson 7.A. So remember I said we're gonna split up chapter 7 into 3 tests. Well, this is the third section. So 7A is going to talk about general angles and radian measures using the coordinate planes and what we know about that. And just a little foreshadowing, 7B is going to be about the laws of sine and cosine. So they're kind of unrelated, but it's a little like advanced topics in math that you might experience when you go to Algebra 2 or beyond. So let's get started. First, I want you to write down the definitions here. So we are talking about general angles in a coordinate plane. So in the coordinate plane, an angle can be formed by fixing one ray called its initial side and rotating that ray called the terminal side about the vertex. So if you can think about this here, here's our coordinate plane, right? This is my y-axis, this is my x-axis. If it is in standard position, we are here along the positive x-axis, okay? That's what this says, an angle in standard position if its vertex is at the origin and its initial side lies on the positive y-axis. So right here, right at the origin, that's the that's the vertex, I'm sorry. So in the next picture, so if you need to pause the video to copy this down, please do so. But I have a better image in the next slide I want to show you, and I would like you to copy it down. So here it is, right? Here's our y-axis, here is our x-axis. If this terminal side was down here on the initial side, it would be in standard position. So if you imagine it like arms opening or like a mouth opening, it rotates around to the left, and where it stops, that's its terminal side because it terminates, okay? So this angle measure is what we're going to be able to look at and get, right? Obviously when it's in standard position, it's 0 degrees. Once we get to this y-axis, that's 90 degrees. And then if we go all the way back down to the x-axis, that's 180 because it's a straight line, right? And we keep going about. Then if we are down here, it's 270. If we come back up to the positive x-axis, that's 360. And we just keep counting in increments of 90, right? Because each of these are right angles, right? The y and x-axis are perpendicular to each other. Okay, so maybe make sure you copy this down. All right, so the measure of an angle is positive if the rotation of the terminal side is clockwise. So it's positive if it's going this way, okay? And it's negative, I'm sorry, I said clockwise, I meant counterclockwise. Positive if it's going counterclockwise, like opposite of a clock, and negative if it's rotating down, right, like that. That's negative. All right. The terminal side of an angle can make more than one rotation. Like it can be bigger than 360 degrees. So it could be 540 degrees, 1080 degrees. You will see, we'll do some examples. All right, so here we have some coordinate planes. We're going to draw an angle. So remember, when I start at that positive x-axis, first, let's mark up some things here, right? So we know up here it's going to be 90 degrees. We know this is going to be 180. And this is going to be 270 down here, okay? So it's positive, so I'm going to rotate up. And it's 240, so it's bigger than 180, but it's not quite to 270. I'm going to say it's about here. That terminal side would be about 60 degrees. Okay? So that would be my sketch, my drawing. Okay? Let's look at 500. So that means I have to make more than one rotation. So we know this is 90, 180, 270. That's going to give me 360 once I get back there, okay? It's positive. I'm going to go to the right. So bigger than 360. 360 plus 90 is 450, so then I need 50 more. about there. Okay, we want to make sure we draw our terminal side. Okay. You don't have to put this 60 degrees like I did there. That was just me like saying what that measure is here to that. I'm just going to leave B the way it is, okay? That is 500 degrees right there. Like that's how many, you had to make a whole rotation and then a little bit more. All right, so negative 50 degrees, that means I have to go the other way. So if I'm going negative 50, remember this would be negative 90 down here since I'm going the other way. And then it would be opposite, right? This would be negative 180. And this would be negative 270. Okay, just to give you a little visual there. So I'm going to start, and I'm going to rotate down 50 degrees. So it's not going to be too far. I don't want to go all the way. Because if you think about half of this, right, like half of this 90-degree angle is 45, so it's a little bit more than that. So it is like, you know, as long as you're in the right quadrant, you'll be fine. All right, coterminal angles. The angles 500 degrees and 140 degrees are coterminal because their terminal sides coincide. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. Okay, so it just means, like if we look at this picture, if we look at C, right? I have, this is 50 degrees, so 50 degrees, and if I went the other way, I'm going to use like pink, and I go the other way, and I come to here, that's going to be coterminal. That measure is going to be 310 degrees because it's positive because I rotated the other way. So 310 and 50 degrees are coterminal angles. It just means one goes one way to that terminal side, one goes the other way. And you can go more than once, you know. I'm going to show you how to calculate it with math, but that's just a little visual of what it means to be coterminal. All right, so let's look. It's like, okay, we need to know the multiples of 360. So, you know, 360 times 1 is 360, 360 times 2, 720, 360 times 3 is 1080. Okay, so you need to know those multiples because you're going to add and subtract. Let me just underline here. Multiples of 360. So 360, 720, 1080. Those are the numbers you're going to be adding and subtracting to find your coterminal angles. Let's look at some examples. Here we go. Find one positive and one negative angle that are coterminal with the following. So I'm going to take this negative 45 degrees and I'm going to add and subtract multiples of 360. I do prefer to work with smaller numbers. So since this is negative 45, I'm just going to take negative 45. I'm going to add 360. That's going to give me a positive coterminal angle, which is positive 315. Okay. Then I'm going to take negative 45 and I'm just going to subtract 360, right? Adding and subtracting multiples of 360, and I get negative 405. That is coterminal. If we wanted to draw that, it would be like this, okay? Now I'm going to do my negative in red, okay? So negative 405 is going to go like maybe 270, oops, 360, and then I need a little bit more. Right about there. So let me use pink, I guess, for 315. So that I'm going to do, and it's going to stop at that same You see that? That's 315, right? Because if I go here is 180, there's 270, and I need 270 and 45, right? And that gets me there. All right, so that's my little visual for you. So just this is what we're doing here. We're just finding one positive and one negative just by adding and subtracting multiples of 360. So for 395, if I want a positive, I can subtract 360 and get 35 degrees. That's positive, and I got it by subtracting. That's fine. Now thinking about that, to get a negative, I'm going to need to subtract bigger than 360. The next multiple is 720. So let's take 395 minus 720. That's going to give us negative 325 degrees. Okay, so now I have one positive, one negative coterminal angles. There are my answers. I will spare you my little fancy drawing artwork because I know you guys love it. All right, so let's check this out here. All right, so now let's look at even more examples. Okay, I have 4 more examples here. So first we need to draw an angle with a given measure in standard position, then find one positive and one negative coterminal angle. So I'm just going to take A, put it right here. Oh my goodness. All right, so it's 65 degrees, so that's not too far. That's going to be like about right there. Now I need to add and subtract multiples of 360. So 65 minus 360 is negative 295. Oh. And 65 plus 360 is 425. So 425 degrees and negative 295 degrees. All right, let's look at letter B. Okay, real quick. So this is 230 degrees. So we start here. We go up 90, 180. 180 plus 50 is going to give us 230, so it's going to be right about there. Good enough. All right. So my blue angle, that's 230 degrees. Coterminal to that, so if I subtract 360, I get negative 130. And then if I take 230 plus 360, that gives me 590 degrees. All right, we don't have to draw those, but you know what that looks like. All right, so let's take a look at letter C. Okay, so we start with our X and Y axis. This is 300 degrees. So that means I'm not making a complete rotation, but I'm gonna go 90, 180, 270, 270, and 30 more. We'll approximately say about there, right? So that would be my angle in purple there. That's about 300 degrees. All right, so if I subtract 360, it gives me negative 60 coterminal. And then take 300 plus 360, and we get 660. It's positive. Beautiful. One more to go. Let's use orange, I guess. All right, so we'll just do D here, and make our Y and X axis. Okay, so this is positive 740. That's big, okay? So that means we're going to have to go, we make one full rotation. So we know once we get here, that's 360. 360 and 90 is 450. 450 and 90 is 540. 540 and 90 is 630. 630 and 90 is 720. Okay, so now I've made 2 full rotations and I need 20 more. About there. Okay, you know, we do the best we can. All right, that looks amazing. By the way, I just want to say I really like my artwork today. So this is 740 degrees. We made a couple rotations, but we made it happen. Now let's find negative coterminal angles. So we already know 720 is 2 rotations. That's 2 multiples of 360. That's not big enough. I need to subtract 1080, which is 360 times 3 to find my negative coterminal angle. And that's going to be negative 340 degrees. Okay. Now we take 740 and we can subtract 720, right? And get positive 20 degrees. I mean, you can have, like, honestly, there are infinite number of positive and negative coterminal angles depending on how great of a multiple of 360 you're going to add and subtract. But I like to, you know, I like to keep my numbers small anyway. Okay, so that is basically the gist of general angles. Now we're going to talk about radian measures. All right, radian measure. Angles can be measured in radians. To define a radian, consider a circle with a radius r. Okay, here's my circle. On the coordinate plane with radius r. Centered at the origin, okay, just like our angles we were drawing. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So this is arc length here. We'll talk more about that in later units, but please make sure you copy this down. Pause the video if you need to. Please copy this down so you understand what it means. All right. Now, because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. Degree measures and radian measures are therefore related by the equation 360 equals 2 pi radians, or 180 equals pi radians. If you need to pause this to copy that down, that's okay. Here is how we're going to convert between degrees and radians. So to go from degrees to radians, we're going to multiply the degree by pi radians over 180. Then to convert radians to degrees, we're going to multiply the radian measure by 180 over pi radians. This might look a little confusing, but when we do some examples, it will be a little easier, I believe. Okay, so to convert the following 2 radians, so we're going from degrees to radians, we're going to multiply by pi radian. And I'm only going to write this out this time. I'm not going to write it out the rest of the time. So pi radian over 180. What I want you to put in the calculator, because you can't put pi radians in the calculator, what I want you to put in is really just 125 over 180. And make sure you reduce that. You will lose points, major points, if you do not reduce these terms in radians, okay? So you should get 25 over 36. And now make sure your final answer has pi in the numerator. Okay, 25 pi over 36 is radians of 125 degrees. Now, I'm going to do example B, but I'm not going to write this out like I did before, okay? So I know I'm going to multiply by pretty much pi over 180. But I'm not putting pi in my calculator. What I do is simply cross simplify. Make sure I put pi in the numerator, and then 135 over 180 is 3 over 4. Okay, so negative 50. Again, it's going to be negative 5 over 18. Make sure pi is there. That is radians. Okay, you're basically just dividing by 180, reducing that quotient, and putting pi in the numerator. Just down and dirty, easy peasy. You can do it. I know you can do it. It's just weird, but you can do it. All right, that's going from degrees to radians. Divide by 180, put pi in the numerator. When we go from radians to degrees, I'm going to write it out this first time, okay? So I'm taking negative pi over 12, and I'm going to multiply by 180 over pi radians. What happens is the pi's cancel out. What I have is negative 180 divided by 12. And then that gives me negative 15 degrees. Okay, there's no more pi, it's all in terms of degrees. The pi's cancel each other out. So you're basically just taking whatever you have here and multiplying it by 180. So here I have 5 pi over 4. So I multiply by 180 over pi. Pi's cancel. 5 times 180 divided by 4. 5 times 180 is 900. Divided by 4 is 225 degrees. All right, last one, multiply by 180 over pi. Pi's cancel. I have 180 over 10. That is equal to 18 degrees. Don't forget to put your degrees. It's important, right? This is how we go from radians to degrees. We multiply by 180 over pi. To go from degrees to radians, we just flip it. We multiply by pi over 180. Pi over 180, okay? Just don't forget to put pi in the numerator, not in your calculator. All right, so today's homework is a worksheet, number 39. Do your best. I would suggest that you open Paint or use the comments in PDF so that you can use a pencil and draw on there. I would like to see your drawings as much as possible. Maybe you could use Active Inspire, or maybe you can just take pictures of a notebook for those of you that are, having trouble showing me your work. All right, I hope you have a great day. Thanks, bye.